Hello, everyone, and welcome to Researcher's Desk. Today with us, we have Paul Glantz and Erik Huss, who are going to talk with us about Svalbard, which Erik certainly often refers to as, he says, a canary bird for the climate crisis, or say in English, often say a guinea pig for the climate crisis, and that what's happening globally is happening faster there. It's going to be really interesting hearing from both Erik and from Paul. Paul's done a bunch of research out there, just newly published an article which is telling us about that warming in Europe can be shown to be double so fast. Now that's not what he's talking about today, but that article is available via the Researcher's Desk newsletter, so do read that. Those of you joining, please do remember to turn your cameras off for the recording. Thank you very much. And I'm going to now hand over to Erik and Paul, who are going to take us through what's happening in Svalbard. Welcome, both of you.
Thank you. And I will start, and lovely to do this together with Erik. And we talked very much about the summer, what's happening in summer in Arctic with the reduced albedo effect, but not so much what happened with the warming in the winter. So that I will focus on. So I will try to give a part of fast warming occurring in the Arctic region. So much we'll talk about positive feedback, but I would also like to take a look at our latest study. It was published 1.5 weeks ago that Alasdair mentioned, a really fast warming over Europe. You find the link and the text in Stockholm University homepage. And so there we also talk about positive feedback. The Southern Europe have a much drier climate today then. So please go to that and take a read. Now I will start my screen here, and we will jump back to the Arctic region. Just fix some. There is done. And now you see my slides. Good. So this figure illustrates, no, I go back to this. Sorry. So the title is Feedback Mechanism of Arctic Winter Amplification and Loss of Sea Ice. And notice particularly northern part of Barents Sea, Svalbard region, so to say. We really have a strong increase in the temperature, as you see. So I will try to expose possible reasons for that. I don't have the full story of it, but I think I could contribute in any case. And so we could continue with this picture, but we have to think about, now we're talking about Arctic winter, we have the polar night. So if I take my pointer here, let me see. Yes, there I have it. So this part, the solar radiation, we have to exclude. This is not included in what's happened in the Arctic in winter. What we have to focus on is the infrared radiation, a cooling effect of the infrared radiation. But of course, you could also have the clouds, the greenhouse gases, re-emitted the infrared radiation to the ground. We also have to think about atmospheric transport, oceanic transport. Arctic is very sensitive to the global warming. Even in a natural situations, Arctic occasional is influenced by high pressure system moving up there. And of course, if we have a warmer planet, more of higher temperature air is moving up, and also more of water vapor. We should also focus on this heat flux. Heat flux is the energy that the planet is absorbed and heating up the atmosphere, here in form of sensible heat flux, here in form of latent heat flux that are emitting water vapor then. So if we go back and take a look at the really strong increase in the temperature, and here I have taken out the northern part of Barents Sea, an average according to December, February. And here you see the number in the warming, +9 degrees, according to an average according to the latest decades, minus the decades for latest. But notice also, not much has happened, approximately, I would say, from around 2005. So if you play with this and put the linear regression, you more or less don't see in the increase in temperature. So it seems that we have some around this year, a shift in the climate regime, I would say. And what could have causing that? And before I coming back to the main cause of that, what we think, we should also think about that, as I mentioned, Arctic region is very highly sensitive to if we get a shift in the transport of air masses. And therefore, I will shortly describe that we have also investigated transport of the air masses. And the simple line you see here is depicting air masses that have moving back in time 7 days from the Svalbard area. So this is an indication, give us indication how the air masses have transported. And to doing this more in a more sophisticated way, you can introduce a grid field, what we have here, with the middle according to the Svalbard area. And you introduced a symmetric grid. And when you play with all this trajectory, which is describing air mass transport, you can count them every time, or how many have passed this particular grid cell, or this one, or this one, or this one. And we play with 9,000 trajectory according to this period. And once again, it's according to the winter period. And we have 4 trajectories per day. And we calculate them, introduce them in calculation, and then we color coded it. So it's possible to see a pattern in the shift of the transport. So here you have a frequency plot for all this transport and these trajectories, and that we have color coded. So the higher frequencies indicate for this period more of transport to the Svalbard area over the pack ice, dry and cooled air. But when we take a look at a later period closer to the present day, we see a little more shift in the transport, even from Scandinavia, what we see here. And this is also confirmed by in situ measurement of the winds, the local wind by this group, these persons, I would say. And then they come to the conclusions for this period that they find higher frequency of cold air and dry air from the pack ice. When they go to the later period, they find a higher frequency or humidified air and warmer air in a similar way that we see here then. You can also make it more simple. From the temperature curve, you can pick out the coolest year and the warmest year, what we have done here. So from that, if you go back to the temperature curve, you see that 98, 2003, 2004 was really cold, while these years, what you see on the right, was really warm. And then you take a look at the difference in how the air masses have influencing the Svalbard area. And particularly for the warm air, you see much more of transport from the open ocean that you have in the south. How about the ice age when we're comparing these cool years with the warm years? And you see, particularly for northern Barents Sea, then that we have less ice for this warm air. So we believe that this highly impacting the warming that we have for this area. You can also take a look at a heat flux that I mentioned, which is really important parameter to investigate. And when we take a look at the trend according to these 4 decades, we see a lot of increasing positive trend in the heat flux. So all this energy that are closed or stored in the ocean is coming up and warming the atmosphere. And just introduce now that a feedback loop that we think play a role. So from the beginning, we have a difference, more occasional warm and humidified air. We increase the temperature in the air, which means increase of infrared radiation in that direction. We reduce the sea ice, we increase the heat flux, and we pop up with a feedback loop similar like this. We have not particularly investigated the aerosols and clouds. I should mention that, and particularly clouds, we of course seems to be affected by more humidified air. Okay, I just also took another month to take a look at, and that is for October here. And I also take, well, yeah, what you see here, a difference in the sea ice when we're comparing the 80s with the latest decades, and particularly when you take a look at this figure with the temperature. So here is a problem that we have in the summer Arctic, that we have started to melt so much ice in summer that this will continue also in the fall. And then you see the huge amount of heat flux that are increasing the temperature. So the Arctic is a little bit more attacked from two places, so to say. Conclusions from the Northern Barents Sea. A warming of about 1 degree is found in winter since the beginning of the 1980s. Also, more or less no increase appear after around 2005. Ice decline in winter has a huge effect on the Arctic amplification. A change in atmospheric circulation appears as well. Alasdair, I don't know have I spent more time than you gave me.
No, not yet. You're actually on 12 minutes.
Okay, good, very good. I mean, Erik also and Alice also pointing up some consequences of the Arctic amplification. And I mean, it's a little bit of speculation in a way. I mean, you find studies that are showing that the fast warming that are occurring in the Arctic region have influencing the jet stream. But you also find other studies that have not found that. So it's an open question, I think, but it's relevant to speculate on it in any case. And particularly when we talk about the climate also in Europe, because it's a connection what's happening in the Arctic and in Europe, and particularly when we talk about the jet stream then in a sense. But we remember, we talk more about, I think studies also talk more and more about that the jet stream is blocking anyway. And we remember the summer of 2018, for example. For me, it was really extreme. I haven't ever experienced a summer like this that started more or less in the May and ended somewhere in the August. And that was a really long period with blocking of the jet stream. But maybe we could coming back to consequences of Arctic amplification. I often think about what period is it when we are releasing all this ice. I can't say it. I don't play with it. I mean, I play with this increase in the temperature, and well, it has gone very, very fast up to 9 degrees for the Barents Sea. But at the same time, as you saw, if we're taking the latest 15 years, we more or less not see an increase in the temperature. So it's difficult to also speculate on when or if the ice will disappear completely. Okay, I think I am there.
Thank you very much indeed, Paul. I'm going to move straight on to Erik, and we'll take questions at the end of the talk. Erik, the floor is yours. Thank you, Paul.
Thanks a lot, everyone, and I really appreciate being here. Now you will see, I will show it's more of a scientific adventure, and I can see that in the audience we have both the founder and the expedition leader of this expedition, Jonas Paurell. He's sitting in the mountains of Jämtland right now, where this picture is from. I'm in the Haglöfs store in Stockholm. And Susanna Hancock, the other scientist, also joined me. So now I have to watch my tongue a lot. So this is what I will talk about is an adventure that we did in May this year, this spring. It's called the Jubilee Expedition. And it's to celebrate the adventures of the scientific adventures of Adolf Erik Nordenskiöld, the Swedish scientist. He planned to go to the North Pole 1872, but they failed because it was too much snow. So we'll see here. This expedition was financed by Carnegie Funds, Carnegie Bank, and they also funded the expedition of Adolf Erik Nordenskiöld. And you can see it's Haglöfs, a lot of sponsors needed to survive in these conditions. And also Färgfabriken, because we plan to have a photo expedition, a book, and also a movie about this. And it's with skis and pulks, no machines when we walked over the ices. So this map is actually drawn by Adolf Erik Nordenskiöld 150 years ago, and you can see here that's how he wants us to look at him, you know, a real polar explorer with his ship Polheim that was stuck in the ice for 2 years. And they tried to, you see this red, let's see, a laser pointer here, from Mussel Bay all around to Northeast Land. And this is the biggest glacier in the whole Europe. This is 550 kilometers, and that's Longyearbyen. We plan to do this route, but I will talk what happened during this Jubilee expedition. As Paul mentioned, that's the North Pole. Between North Pole and the Nordkap, you have this Svalbard. And Svalbard is the whole archipelago. Spetsbergen is the biggest island. We had to make a route change already in the beginning because you can see here there's a little strait between Nordaustlandet and Spitsbergen, and it was too scary, too little ice, and it was moving too fast. So we didn't dare to go, so we had to stay in Spitsbergen. So we had to have help to the northern part of scooter expedition. It's 300 kilometers to go with scooters, took a whole day. But when they left us, this is how it can be when it's really, really nice. And it's marvelous, between a few hundred meters to kilometers of deep ice all over Svalbard. And it's so beautiful that sometimes you just stand there looking, breathtaking of these areas. The route change number 2 we had to do already in the beginning, because we were up at the Polheim station where they overwintered, the whole team of Nordenskiöld. And we planned to go around the corner on the northern edge of Svalbard, but it was too bad weather and too much polar bears. So everyone said it's a suicide to go there because you won't recognize the polar bears in due time. So then it's too late. You look at these 2 black dots, the ice, but you think you see them all over, but luckily we didn't have any encounters. But way up here, Susanna Hancock, she examined all the plastic pollution that we can find here. And this is an extreme area, really remote from civilization, but even here we could find plastics. And also these old wooden logs that probably were from Canada, thousands of years old, but we haven't got a exact dating yet. but probably pine trees or something that survived through the ice and stranded in Svalbard. And this was actually the guide that kept us alive from polar bears and crevasses, Christer Jonsson. He lives in France. The first 4 days, we had to dig ourselves in because it was a storm that never ended. We had up to 28 meters per second and also around 30 degrees below. So it's the chill factor of about 45 minus. So go out and do your needs was kind of a survival mode, I would say. And you get to learn people really a lot when you stay in those tents. And most of the days, many days, it was like this, because normally in May, it's nice weather. But since it's so much open water, you have so much moist coming in and creating this super cold fog. So we had to go on GPS and altimeter all the time. And it's really, really difficult when you don't see, when you have this whiteout. So that was a struggle. Like I told before, we in the information, we had some findings that actually nobody had seen before. First, we came down from the polar plateau down to another big ice stream. And around the corner was this huge field, 0.5 kilometer wide, with just collapsed ice, with ice blocks that were about 20-25 meters high. And we couldn't see it on the map. It was supposed to be a lake. But discussions with glaciologists at Svalbard, we figured out that probably this must have been lake out first, like a Geochemistry that collapsed this winter or in the early spring, because it looked really like a catastrophe area. So we will continue to examine this, and probably we have a theory, but we're not sure. A bit further south, we found this area. It wasn't even a receding glacier, it was a complete extinct glacier. You can see the lateral moraines and the terminal moraines here, lateral moraine up. So it used to be a big glacier here, but it was totally extinct. So we had what shall I say, a silent minute for this glacier. It was totally extinct. And I wasn't prepared to see this at this far north. The route change number 3 we had to do when we came down to Nordenskjöldbreen. We planned to go all the way down to Longyearbyen, but it was such a rapid melt. So the big rivers opened up several weeks or maybe a month earlier than normal. So we had to follow this Nordenskjöldbreen. And we had actually a little lake, subglacial lake coming out on the surface. So we had to rush on the side up to the left here because of this big stream, water stream. But finally we came down to the sea ice. And you see here, this is a terminal moraine, and this is the Nordenskjöldbreen that is several kilometers wide. And when you look at the map, you can see that 3 kilometers of the ice has retreated in just 100 years. That's the whole Storglaciären, for those who have been up in Kebnekaise Mountains. And even this is a rapid decrease, but Nordenskjöldbreen is fairly good. It reaches a lot of snow, reaches this glacier. So this is in a fairly good shape compared to other glaciers in Svalbard. And the perspective of this is that we made some measurements here at the Nordenskjöldbreen, and it looks like it's a fairly good shape. But when you look at the whole Svalbard area, like Paul Glantz mentioned, if you look at the whole year, not just the winter, you can see it globally, we have like 1.2 degrees warming in 120 years. At Svalbard, this is the Svalbard curve for the annual mean temperature from 1890s. You can see that the latest 50 years, you have a really rapid increase. And that is about 1.25 degrees per decade. And that is about 7 times faster than the global increase. So these areas that are really sensible to changes actually change much faster than the global. Meanwhile, banks, Swedish banks, international banks, they are financing the oil companies, Gazprom, Exxon, you have the Norwegian companies. They are planning to increase their oil extraction with 20% the coming 3 years in the Arctic. So it's really hard to grasp how you can plan this. And when we came down to Longyearbyen, finally, I'll show you a picture where we were rescued from the ice. But when we came here, from just one day to another, all snow disappeared. So there were mosquitoes all over. So they have never ever experienced a warmer May month ever in Longyearbyen. So they didn't have time to put the snowmobiles in the garage or in their storage areas. So it looks like a chaos when we came there. But we also managed to have a little, the smallest and northernmost climate summit in the world. So we had this is a place for the climate summit, and it will be in the movie what our experiences were and what we think about the global climate. And this is just driftwood in front of the Nordenskiöldbergen. But one thing we said, that no matter what you do, leave a positive footprint. And this was actually outside a bar in Svalbard. And the bar was actually called Svalbard. Pretty good name, I think. And this is the movie maker. He's been making movies with David Attenborough. So he's a real skilled Dutch and Philippine guy who makes this. And like Alasdair said, in Sweden we say this canary bird really recognizes changes much faster, or the guinea pig if you want. So if we learn more what's happening in Svalbard, we might learn much more what will happen to the planet, and we might get a hint of what we have to do in the future. And the last change we have to do, because we were supposed to get a boat ride at the Cape Ekholm, but it was such a rapid melt of the sea ice, so we had to rush into the shore, and even you see in the background it's no snow, so we had to call a cruise ship in the fjord to get us up. So this is the last image of the whole gang: Jonas, Christer, me, Susanna, Martin, and Awi. And all survived. We're happy, and we had a really nice dinner and a good beer on the ship. So thank you for listening, everyone. It was a pleasure. I will end there. That's a Greta font. Thanks.